Good afternoon, everyone. It's another weekly video about climate and meteorology, and it's time to discuss something that I really honestly didn't know what I was going to talk about this week because there wasn't really any breaking news or anything that was significant out there. But then I ran across a Mr. Steve Mallowy. I think I spelled that right. It's Steve Millow. Apparently, I should have known better when it said junk science. But I decided to say, okay, let me interact with this guy because he clearly doesn't understand what's going on with the dynamics in relation to what happened in Texas, which I discussed in a previous video, which I will have connected onto this one, and also how you can have a warming climate and at the same time have really below normal temperatures. And part of that, this is one of the books you really want to pick up, Introduction to Dynamic Meteorology by Mr. James Holton. It really provides a lot of great information on understanding the physics behind this phenomenon. Now, when I say this, this video is not meant to be political in any way, shape, or form. Just the physics involved in it and how you can have these two factors at the same time. So, in terms of global temperatures, you can have a warming environment, but at the same time have pockets of very cold air. And the reason why that happens is because the atmosphere is always looking for a balance. So if your overall environment is warming, but then you have extreme warm pockets and cold pockets, what's happening is that the atmosphere is trying to create a balance on a four-dimensional plane. On both the stratospheric and ionospheric up here, and also at the boundary layers. So what happens in this case is that you end up with a lot of disruptions. Now, unfortunately, those who support AGW and those who do not, and everyone in between, they make a lot of mistakes in conflating between what's going on with the weather and what's happening in terms of climate. So when people say, oh, well, the climate change is connected to this event, it becomes a lot of misleading, I guess, jumping to conclusions. So first of all, what happened in Texas can be connected to climate change factors. It does not mean that everything about it was driven by climate change. So, which is why when they say, well, this happened 100 years ago, yes, it did. The reason why it's a factor of climate change in a warming climate is because of what happened with the sea ice. So this year, and as I discussed in the previous video with the Texas cold outbreak, you had significant environment in which the sea ice was really missing around Siberia. And when I saw that, I said, uh-oh, this is going to be interesting, because there's a theory that when you have this cold, this lack of sea ice, what happens is that you start to set off a trigger which allows for heights to build around Siberia, and it causes those heights to build up into the stratosphere and basically disrupt the polar vortex. If you go check out a Dr. Judah Cohen, he does a really great job. Check out his Twitter feed, Judah Cohen, or you could just Google him and check out all of his research. Really does a great job of explaining how this process works, and I think he does something every Monday, basically explain what's happening with the stratosphere and then provides a theory. Now, does this work out all the time? Which is one of the questions I had, where they said last year we didn't have this happen and the stratosphere, and we didn't see these cold outbreaks. So how can you claim that that is a factor? Well, that's not exactly true. Last year was another one of those freak occurrences, and I actually explained why the winter forecast last year went up in flames because of it, because we had some cold air leak into the ionosphere, and that cold air got into the stratosphere, which allowed for the polar vortex to rapidly intensify and overwhelm the boundary layer conditions, which were originally thought to allow for disruption of the polar vortex and another threat for high latitude blocking. So as a result, the polar vortex was very strong during the winter, but in March, when we had some snow events around the mid-Atlantic and we had some disruptive cold events in Europe, the polar vortex weakened as expected, but it was delayed because of what was happening with that cold air leaking in. So this is a great point in discussing the influence of climate, what we do on our climate, and also how you forecast. This is why I'm always skeptical and always concerned when some media outlets put out these 30 and 50-year forecasts, because you're dealing with too much chaos in those forecasts, and you're dealing with a lot of uncertainties and a lot of factors that can mislead people. So that is a great example of how you can have that environment, but at the same time not get the same relationship. Okay, so that's what happened last year. This year we had no such influence. So you had the lack of sea ice, which again was a feature of a warming environment overall, which was driven by the addition of CO2, and we can focus on that, on the CO2 factor, because in this scenario we didn't have any type of geological factors that caused that lack of sea ice. There wasn't any type of warm anomalies coming from the subsurface. This was clearly driven by a surface-driven anomaly, warm anomalies in the Arctic, which as a result started to show up late last winter, lingered on into the summer months, and then continued into the fall and the winter months, which unfortunately gets us to today. So that process is what set up the disruption. Now, that doesn't always mean that you're going to get a major Arctic outbreak or a historic one. It just means that the environment is in place to allow for that situation to take hold. Sometimes that happens in China, see 2006. Sometimes it happens in Europe, see last year. Or sometimes, unfortunately, it happens right in the center of our country. Next year, maybe it's the eastern United States, maybe it's around Europe, don't know. Can't say. But I can say that the physics behind it is very well understood. Now it's a matter of just trying to figure out where that lack of sea ice is going to influence your polar vortex evolution in the troposphere and the stratosphere, two different levels, and how that's going to play out in your pattern. Okay, and that is where seasonal forecasting gets pretty tricky sometimes, but it's a challenge that frankly I love to take, because every time that you're wrong, that is when you start to learn and you start to understand, okay, this factor influenced the forecast. So never take anything as an absolute, but don't ever ignore influences that are clear. So again, this is a great example of, no, the world isn't ending, but yes, the world is warming. Okay? And also at the same time, you don't have to be in Team A or Team B. Just follow the physics and understand what's going on in the science. That's all. And that's all you have to do for today. So I hope I answered your questions. If not, definitely drop a line down there. I'll try to get to you or make another video on this, because I think it's really important to explain what is happening and take it from a point of saying, okay, these guys are too extreme. These guys are too extreme. This is where the science is. This is where the physics is. And then you go from there. Have a wonderful day. And as always, stay safe out there.